All right, in this lecture, we're going to talk about another form of flow control in Python, and that is loops, looping structures, specifically for loops and while loops. So we'll start with for loops. I'm going to start by defining a list, and I'll make the list just for demonstration purposes or to kind of show how general looping structures are in Python. We'll start with a list that's heterogeneous. I will say it wouldn't be a normal thing to do to loop over a heterogeneous list necessarily, particularly in numerical processing. Typically, we're looping over to perform computations or something like that. And that wouldn't be the case if you had this heterogeneous structure. In this case, we have an integer, a floating point number, and a string. So we're going to create this list, and then the syntax for a for loop will be for, I'll say, item in a list, print item. And so if we just go ahead and execute this for now without kind of further ado, you'll see what happens. It prints the items one by one to the screen. Okay. Now, this small loop is the same exact thing as if I were to do this kind of thing. So that is, assign the first value of a list to item and print item, and then reassign item to be the second value in the list and print that, and then reassign item to be the third value in the list and print that. These two things are identical. And in fact, what I've written here could be said to be the unrolling of the for loop. Of course, if our list had 1 million items in it, we wouldn't type out 1 million lines of code like this. The for loop is much easier to read. So since you've seen the equivalence of the two, let's back up. In fact, I'll just delete this cell and back up to the for loop here and investigate what's happening here as each iteration through the for loop occurs. And to do that, I'm going to use something called a debugger. So what I'm going to do is I'm going to put what's called a breakpoint right here on this line. And when I run this cell, every time through this loop, the code is going to stop on this breakpoint, on the second line, and we'll be able to inspect the current values of the variables over here in this variable inspector. So let's go ahead and just start it. And you can see the orange line highlights the line it's stopped on, and over here there's a lot of information. The main thing that we're interested in here, you can ignore most of it. The main thing we're interested in here is the value of item, right? So item, name of course is item. It's of type int, integer, and its current value is 1. If I were to hit play here, meaning this will restart the for loop, it will go on to the next iteration. You'll see the first item printed to the screen here because this line of code hasn't been executed yet. When I hit play here, this line of code will be executed and the loop will repeat itself. So if I hit play again, you see that the first item was printed to the screen. We've stopped on this line of code again. And now the current value of item is 2. We can see it's of type float. It's of type float because we forced it to be that by putting the decimal place there. And of course its value is 2. If I hit play again, you'll see it print to the screen. There it is. And an orange line here indicating that the code is stopped on this line once again. Now the value of item has been reassigned again. This time it's of type string and its value is hello. And if I put play again, you will see that print to the screen, and this time this debugging process will stop because we've exited the for loop, and as is the case there. So you see this is gone. So it's often the case when using for loops that we just want to iterate over a monotonically increasing set of numbers. In that case, say the number 0 to 10 or 10 to 100 or something like that. We can use the range function in Python. So in this case, I'm going to say for I in range 10. Now I just use I here in place of item. This is a variable. It could be anything. You can name it anything you want. In this case, what we'll do is we'll actually print, say, I plus 1 and execute that. And you see, of course, we know in Python is 0 index, so the range function actually starts from the number 0, right? So what's printed out here is 0 plus 1, 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1, all the way to 10. Another example of what we can do with the range function is, again, used to, I guess, just for demonstration purposes, instead of using I, I'll use J. Again, it's just a variable. It could be anything. In this case, we'll go from, say, 10 to 21, printing. In this case, I'll just print J. So there we get from 10 to 20. That's just due to the nature of the range syntax. It takes up to up to 21, but not including 21 in increments of 1. It's often the case that as we're looping over something, we want to store the values in a list itself, and we can use, we already know, we've learned about lists, and if you recall the list append function. So if we start with an empty list, I'll just call it a list, and we'll start like that, and we can then just say for item in range 10. Then we want to take a list and append item squared. Right? So this will give us 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, and so on. Okay, if we execute this, it's going to appear like it didn't do anything, but of course the updated values are stored in a list now. So each of these item, as it took on each value from range, was squared, and then its value was appended to a list. There is a shorthand syntax for constructing lists on the fly like that. They're called list comprehensions in Python. And so to repeat this same task as a list comprehension, the way we would write that is using square brackets. We would say item squared for item in range 10. And you see we get the exact same answer. This may be a little hard to understand at first if you don't truly understand looping structures. So if you don't have a firm grasp of the structure of a loop, then it might be best to hold on to this for later until you have a better grasp of that. And we can revisit list comprehensions in the future. List comprehensions are, in fact, quite faster in terms of computational time than doing it this way, but nevertheless, they end up with the same output. So another type of looping structure in Python is called a while loop. So a while loop basically evaluates continuously, meaning it will continue to loop while some condition is true. So in order to illustrate this, again using the debugger, we'll first write our loop. Let me start with that, and then I'll explain what's happening. Okay, if I go ahead and execute this, we'll see what happens, right? So in this case, it prints the numbers 1 to 5 to the screen, but let's take a closer look at what's happening, and then we'll examine it in the debugger. So initially, we set a variable called stop condition equal to true. So the first iteration, this will say while true, which means it's going to execute the body of the loop. Also, we set an initial value of I equal to 0. So what we're going to do is, upon execution, we'll print the current value of I. We'll set the stop condition equal to this conditional expression. So the first time through the loop, I is 0. I less than 5 is true, therefore stop condition is true. I will then be incremented by 1, so I is initially 0, we'll add 1 to that, making I 1. The loop will loop back around, evaluate the condition, stop condition, which we already know through the first time through the loop was true, and it will continue. So it will print the next value of 1, which is the next value of I, which is 1 on the second iteration through. Evaluate stop condition. This will be either true or false, and then it will increment 1 again. So what we're going to do is we'll turn the debugger back on. We'll set a breakpoint at this line, and we'll run this code. Again, a lot of stuff over here. Most of it you can ignore. The one thing we're interested in here mainly is the stop condition. So we see that initially stop condition is true, and as we step through the loop one iteration at a time, you see we've printed 0 to the screen. As we hit play, it'll print the next iteration to the screen, and the next one, and the next one, and the next one. If we go up here to stop condition, it's still true. We'll take one more step, take a look at stop condition, and now stop condition is false. That is because, as we know, when I was printed to the screen here, now I must be equal to 5. 5 less than 5 is false. Therefore, stop condition is false. And this time we will exit the loop along, as soon as we exit past this breakpoint here. And that's what happened. I don't like to use while loops because in the event that stop condition is never met, this will run indefinitely, meaning it will lock up your computer. It's called an infinite loop. I always feel like it's better to have a maximum number of iterations that will occur during a loop. And you can achieve a similar structure by using a for loop with a fixed amount of iterations and then using an if statement for the stop condition. So let's look at a for loop that replicates similar behavior. So in this case, I'll say for I in range of 100. This is going to set a maximum value on the number of iterations that can occur, will be 100. We'll just print I. And then we'll have an if statement that says if I greater than 5, break. So what this will do is if this evaluates to true, the break will exit the for loop. So it did, in this case, print I before the break statement. So in other words, on the last iteration through the loop, I was equal to 6. It printed it. This was not evaluated to true until the code got to that line, and then the break statement was executed. So to actually replicate the exact behavior as above, I would actually need to change this just to 4, and then we can have the same type of behavior. But again, now we have no danger. For example, if I made some type of typo in my code that would say, for example, try to test if something that, I is equal to 4.4, which will never be true because I is just in the integer range of 0 to 100. So this will never be true, so our break statement will never occur. But in this case, the maximum number of times we'll print to the screen is just 100. So while it's a little bit unsightly, it does stop eventually. So I prefer to use a for loop with a break statement in places where you might be tempted to use a while loop. However, that's just a matter of my preference. Either is acceptable. So there are a couple of other conveniences in Python looping structures. Well, first of all, we can loop over tuples in the same way that we looped over lists. Of course, tuples are immutable, so we couldn't do any kind of append operation or anything like that. We do have, if you wanted to, in addition to knowing the current value of what you're iterating over, you wanted to have some type of count over that. There's a function called enumerate. So in this example, again, let me define a tuple that this time is going to contain a list of strings. Well, a tuple of strings, we'll say. And if we loop over it, again, we'll just print to the screen. It will print one by one the items in the tuple. However, if we want a count of that, meaning the integer number associated with each place in the tuple, we can use a function called enumerate, which will return the items in the tuple, but in addition to that, the count. So we'll use this kind of syntax. Count will be the integer number, 0, 1, 2, 3. Item will be the actual string that's there. We'll modify this print statement a little bit, I guess, to be a little bit more illustrative of what's occurring. So there you can see it should be clear now. The first item in the tuple, the string A, has the count 0, meaning it was the first entry. Tuple 1 of 2 string 3. So that's what the enumerate function does. It returns the item in the list and the monotonically increasing count of iterations as the loop progresses. We could do something similar with dictionaries. So let's start with a dictionary. If we loop over a dictionary, we can actually have the looping structure return both the keyword and the value. So here we have to add the function items to a dict, and that will return the keyword and the value, and that's printed to the screen. If you only wanted to print the keyword, for example, then you could use the function keys. As we see there. So that's just a couple of additional functions or utilities that are often used in for loops.